Hello, everybody. I'm back. Dr. K. Agarwal, President, Heart Care Foundation of India, Confederation of Medical Association of Asia and Oceania, and past National President, Indian Medical Association. And you are watching Med Talks with Dr. K. Agarwal, 7 p.m. show, every day, non-stop, 158th edition, and specifically focused on COVID. Let's have the headlines of the day. Ever since we have started the Med Talks with Dr. K. Agarwal, the viewership has crossed 1.9 million. In short time, we will cross 2 million viewership. India records more than 25,000 fresh cases and 310 COVID deaths on Wednesday. It looks like that if the graph gets plateaued, it may get plateaued between 10,000 and 20,000. And if the new strain doesn't come, it looks like that India is trying to reach at its plateau. Telehealth evolved more in those 6 months than in the last decade. Maharashtra's health minister announces that the coronavirus vaccine, when it will be made available, will be administered in 2 dosages. UK reports more transmissible virus variant linked to South Africa. Remember, South Africa has 3 mutations in the RBD and RBM. 6 people who arrived from United Kingdom test positive for coronavirus at Delhi airport on Wednesday, but the UK strain has not yet been proved in anybody. Before we go to the subject of the day, let's have our ritual of cleaning our hand. Whenever we invite any friend, we take the gel and we say S for Seedha, U for Ulta, M for Mutti, A for Angutha, N for Nakhun, and K for Kalai. So by this, we are ready to receive our guest. But before that, let's have the topic of the day. Mutations in SARS-CoV2, the UK strain, the original D614G strain, and now the 501 strain in UK and in South Africa. And before that, the cluster 5, we should not forget the cluster 5, which came in Denmark and got abolished, also had deletion of 69 and 70 gene in that. So we'll try to understand what are these mutations, why do they happen, and what changes it can make in our contagiousness, in our virulence, in our diagnostics, in our vaccine formation, in antibody formation, and treatment with plasma therapy and antibodies. To understand this, we need to understand it from the horse's mouth, and that is Dr. Navedita Gupta, the scientist F, the in charge of virology at ICMR. She has significantly contributed to strengthening the public health surveillance of virus infections in India, especially related to enteroviruses, arboviruses, influenza, measles, rubella, etc. She is working at the Indian Council of Medical Research since 2005 in the area of viral infections and vaccine, and is currently the in charge of virology unit at ICMR headquarters. She is actively involved in planning and implementation of preclinical studies and clinical trials of COVID-19 vaccine in India. Over to you, Dr. Nivedita. Welcome to our show. This show will be live for the doctors as well as for the public. And it is likely to be seen by 10,000 to 50,000 people in this week. And we want to know the ICMR's view on the mutations in the virus. Over to you, Nivedita ji.
So thank you, sir, for giving me this opportunity to speak on this elite show. I have a set of 10-12 slides. I would just request for the slides to be shared. Next slide, please. So as all of us know that the SARS-CoV2 outbreak in Wuhan, China, This was identified as the sixth public health emergency of international concern. And in way back in January 2020, WHO had warned the entire world to watch out for the spread of this infection. And subsequently, the virus crossed several boundaries globally, and it was declared a pandemic on March 11, 2020, again by WHO. Full genome of SARS-CoV-2 the sequence was released by WHO on January 11, and this is the accession number that I have mentioned. And once the sequence was out in the public domain, all the countries just rushed towards preparing the primers and probes for providing diagnosis of SARS-CoV-2 if the case was detected in their own country, and so did India. As soon as we got an access to this sequence, we quickly prepared our own diagnostics so to just gear up our preparedness. Now, so our SARS-CoV-2 has almost 79.2% sequence homology with the earlier SARS-CoV that was detected in Hong Kong way back in 2002-3. And the genome of this virus is around 30 kilobase pair in length. Next slide, please. So if we look at the genomic architecture of SARS-CoV-2, the ORF1A and 1B regions, these are the ones which occupy almost 2/3 of the genome of this virus. But there are several other very important proteins like the S protein, E protein, N and M, which are expressed by their respective genes, and several other non-structural proteins are expressed. So this is the diagram which depicts the architecture of the genome of SARS-CoV-2. Next slide, please. Now, first of all, it is very important to understand why does this virus mutate. So first of all, SARS-CoV-2 is RNA virus. RNA viruses themselves are very prone to frequent mutations, which is a part of their natural selection process. So this is the sole reason that many of these RNA viruses do have some proofreading activity, but their ability to proofread and provide nucleotide substitutions is very challenged as compared to DNA polymerases. So RNA viruses are known to mutate. And once a sizable number of mutations are accumulated within the genome, then these viruses may change significantly, and this may affect their transmissibility, cell tropism or binding, as well as pathogenicity of these viruses. Now, mutations can be mainly of three types. These are synonymous mutations. Synonymous is something which will not lead to an effective amino acid change. So even if a mutation is happening, the protein that is translated will not have a change in the amino acid. So these mutations do not have a very serious impact, but definitely they also do have some impact. Then there are missense mutations, which result in changes in amino acids. And these are mutations which will lead to changes in the protein folding, unfolding, expression of several other or exposure of several antigenic sites which were hidden, or hiding of previous antigenic sites. So these conformational changes in the proteins do happen because of missense mutations at times, but not always. Then there are mutations in the non-coding region. So these the effect of these non-coding mutations is very difficult to understand and is an area which is actually a gray area in science. Now, the challenges which eventually emerge due to these mutations may be that there is change in the clinical presentation of the disease or even outcomes of the disease. There may be increased transmissibility of the virus, increased pathogenicity, and it may also pose some challenges to the existing vaccines and definitely in diagnosis as well. Next slide, please. So one thing which I want to highlight is that very frequently I hear people comparing influenza virus and SARS-CoV-2. And people do talk about antigenic drift and antigenic shift, which I just want to explain here that it's very different between SARS-CoV-2 and influenza. So if you look at influenza virus, it inherently doesn't have any proofreading mechanism. So whenever the genome replicates, it replicates with some inherent errors because the proofreading enzyme is absent. So these corrections in the genome do not happen in influenza at all. So when an influenza virus also has the capacity to chop off certain regions of its genome and recombine with other influenza viruses which are present in different species, like in birds or in pigs, and then through these recombinations and reassortments, an altogether different virus is created, and this is your antigenic shift. Now, if there is another form of mutations which do occur in influenza viruses, that is, they keep on gathering a small amount of point mutations as time passes, and a slightly drifted virus is developed after this. And this is what is happening in the current influenza patterns that we see, that the virus, though it mutates, but the mutations are not like chopping and recombination between other species. Whereas in SARS-CoV-2, we do not expect such type of drastic mutations, because this is a virus which has a proofreading activity, and the nature of the virus that has been documented till now and studied and reported by various researchers all over the world, it is reported that still the mutation rates in the SARS-CoV-2 are relatively lower. They're almost 10 times lower than what we see in influenza viruses. And the complete antigenic shift is very unlikely to be seen in this virus. But as I said earlier, being an RNA virus, mutations will happen and we need to be prepared for them. Next slide, please. So if you look at the classification of the SARS-CoV-2, so SARS-CoV-2 right now can be classified in 7 different clades. And all these global sequences of SARS-CoV-2, which are like various researchers all across the world sequence the SARS-CoV-2, and there is a common global database which has been led by WHO, supported by WHO rather. This is known as GISAID, that is the Global Initiative on Sharing Avian Influenza Data. So this global database was developed or was formulated when the avian influenza threat was there way back in 2005. And subsequently, this has become the global database for depositing sequences of influenza and now also SARS-CoV-2. So the common clades of SARS-CoV-2 are the L clade, and L clade is the first clade which was identified in Wuhan. Then there's an S clade, and you can see on the right hand side what is the basis of the classification in terms of amino acid, in terms of nucleotide change, as well as the amino acid substitution. So the clades are L, S, V, and G clade. And after the G clade was identified, there was further changes in the G clade, and that's how the GH, GR, and GV clades emerged. And then whatever sequences cannot be classified into any of these clades are left as unclassified until a further clade is identified for them, and that's the O clade. So as of now, the new UK strain that has emerged has been left unclassified as of now and is there in the O clade, but very soon a clade will be defined for that as well. Next slide, please. So I just wanted to give you a quick snapshot of what we have been doing in India. So in India, we had initiated the genomic surveillance of SARS-CoV-2 way back in March. So what we did is we have a set of 115 viral research diagnostic laboratories in India, which are led by ICMR and the Department of Health Research in the government medical colleges of the country. So we just kept on taking 10 nasal and throat swabs from 30 geographically represented zones in the country. And from March till August, we picked up 10 samples from each month from each of these 30 sites, and we have sequenced them. So in total, we have sequenced close to 3,000 strains of SARS-CoV-2 as of now as a part of this surveillance activity, which is still continuing and will continue till we find a logic to stop it. So this is a continuous ongoing activity. And in India, we see that the G clade predominates, that is the G, GR, and GH, whereas the S, L, and V clades are found in very, very small proportions. Still date, we have not identified the GV clade, which emerged in Spain and subsequently spread to Italy and Singapore. And the sequence analysis data till August shows that there is less than 1% divergence in the genetic structure of SARS-CoV-2 as compared to the Wuhan strain. And the sequencing from the month of September till now is currently ongoing, and that data is also expected to be available within the next 10 to 15 days. Next slide, please. So this is a snapshot of the predominant mutations that have been reported for SARS-CoV-2 all across the world. I will not go into the granular details, but as all of us know, that the D614G mutation has been the most widespread all across the world and has been reported to have a moderate effect on the increased transmission of the virus. And then there are several other mutations which have different effects, ranging from transmissibility, effect on monoclonal therapy, diagnostics, and so on and so forth. Next slide, please. So I'll briefly be talking about the emergence of this new SARS-CoV-2 variant strain in UK. So there was a sudden upsurge in number of cases in southeast of England, starting from middle of November 2020. And this was a great cause of worry. And when the UK consortium reported that a new strain which has 14 non-synonymous mutations, that is amino acid altering mutations, 6 synonymous mutations, and 3 deletions. So this kind of a strain was reported, and almost 60% of the infections that were caused during this period were due to this particular strain. So that raised a lot of concern about its increased transmissibility in particular, and was a cause of concern globally and still is. Next slide, please. So, what could be the possible effects of this variant strain of SARS-CoV-2? Like, all the information that is there in the public domain till now, it's based on the simulation exercises, modeling exercises, but to do exact actual epidemiological and laboratory studies, it definitely takes a lot of time, and this data will emerge in due course of time. So most of the knowledge that prevails regarding this new strain is based on simulation exercises, modeling exercises, and also on speculation. So what could this strain possibly do? It can lead to enhanced transmissibility of SARS-CoV-2, like the earlier D614 mutation, which was documented to enhance the ability of the virus to spread. It can also cause either a milder form of disease or severe disease in humans, that time would tell. Or it may also not lead to any change in severity, that is also possible. Then there is definitely an enhanced concern that this mutation may lead to evasion of the virus to the current RT-PCR detection assays. But I would like to say here that this is less likely to happen in India, because since inception of the SARS-CoV-2 testing in India, we have always advocated use of at least 2 gene targets for detection of SARS-CoV-2. So many labs are even using 3 to 4 gene targets. We have never propagated the use of standalone S gene assays or a single gene target. So this is less likely to happen with us. It may also lead to decreased susceptibility to therapeutic agents such as monoclonals. And then there are a lot of concerns about the ability of this changed or mutated variant to evade the vaccine-induced immunity. Again, this is again a speculation, and it is the experts say that it is less likely to happen, because most of the gene vaccine targets, they actually, the vaccines target large parts of S gene. So mutations in small portions, or mutations as the one arisen in UK, still we are yet to see whether it has any change in the to elicit the response due to vaccines. So that is also a possibility, which is less likely to happen, I would say, at this point in time. Next slide, please. So the way forward that we see is that considering its high transmissibility and the absence of pre-existing immunity in the general population, natural disappearance of SARS-CoV-2 appears unlikely. Though once we have immunity in significant proportion of the population, we do expect to see a decrease in transmission, but there will be some baseline transmission, and we do not expect that this virus will suddenly disappear. Like other RNA viruses, SARS-CoV-2 will also mutate, and we should be prepared for it. However, whatever we see till now, the rate of mutations is low. Now, there is definitely a need to continue the epidemiological and laboratory based studies, which will be very important to understand the implications of these mutant viruses in terms of clinical presentation of disease, transmission of the virus, the effect on diagnostics, treatment, and also on the vaccines. So we need to continue these studies, and also we need to monitor the evolution of the genome of the virus as the transmission increases. So we also need to monitor the trends for emergence of resistance and subsequent effects whenever we have monoclonals or whenever we have effective drugs. So continuous monitoring for genome is also very, very critical. So thank you very much, and that's all from my side.
Thank you, Nivedita ji. And we have time to discuss. So we will like to discuss out. First point you said was that the vaccines are taking the large part of the S protein. So normally S protein has 3 petals, and in all the 3 petals, they have identified 3 different types of genes. And there are vaccines who are coming on nanoparticles, who are using only a miniature pass of a nanoparticle. So I think that those people who are working on nanoparticles, if that particle ends up into a mutation, they may end up into a problem. So all those people who are working on nanoparticles on the tip of the, some people are working only on the tip of the spike protein. So what do you think about that?
So, sir, definitely there are concerns about like mutations arising in those specific portions where the vaccine targets are there. But simultaneously, the vaccines that are designed now, the vaccine manufacturers are very much prepared that as and when the genomic surveillance data emerges, they will have to make some tweaks in the vaccines that they are currently proposing. So, whenever they are targeting small portions, they are definitely prepared to tweak the vaccine as per emergence of genomic surveillance data. And that is why this data also becomes very important to be generated in a continuous fashion.
And what about Bharat Biotech, where we are using the killed virus as a whole? Because we are taking the whole virus. There, do you feel that every 2 months they will have to change the strain?
So definitely not, sir, because when we have a killed virus, and for the Bharat Biotech vaccine in particular, so since it has been developed in partnership with ICMR, we have also looked for the presence of various antibodies to various antigenic domains for Bharat Biotech besides the spike protein. So the data on the immunogenicity towards various antigenic components besides the spike also exists for BBIL. So definitely whole virion killed vaccines do have an advantage in terms that the antigenic portions that are there are much, much more longer as compared to standalone small portions of spike protein. So we do not envisage a problem there as of now.
Do you think that killed vaccines always, like killed vaccine, inactivated vaccine in China, they have 4 months of their experience now. They started that in August. And now the same vaccine is going on in Dubai, in Bangladesh. Do you think that killed vaccine can be used as a bridge in a population? It's a huge population where you can use it as a bridge between infection and a very potent vaccine, because these vaccines will be less antigenic but more safer, safety point of view.
So definitely, sir, as far as safety is concerned, the killed vaccines are always considered to be much more safer, and they can also be used in larger populations where you have serious worries using the live vaccines, like pregnant women, immunocompromised individuals, and other populations. So, definitely, killed vaccine is one option which can be currently used in view of these more potent vaccines to come into picture. Definitely, whatever you said is correct, and I agree with that.
They say that the R value of UK will change by zero point 0.4, and original R value was 2.6, so it makes it 3. But what is the R value in India today? Is it 1 or is it varying from state to state? What is the R value?
So, R value, I do not have the exact figures as of now, but definitely it varies from state to state, and it is definitely not one in India.
Okay, so coming back to one more thing is that we have seen that when we are now showing from 16th of September, we are showing a decline. And we saw a decline in mortality 2 weeks after the 16th of September. And now it is coming to around 25,000 people. And when we say it is going to stabilize, because it is not going to become zero, we don't expect it to become zero. Is there any guesstimate? Is it 10 to 20,000 where it going to get stabilized unless the second wave comes? Is there any model to say at what number it may stabilize? What will be the stability number? I mean, as on today, it is between 20 to 25,000. So do we expect further decline, or it is going to stabilize at 20 and become a plateau?
So, sir, though there have been a lot of modeling exercises, but I would refrain from commenting on this right now
Okay.
because this is something which is, I believe that the input, as far as modeling is concerned, if the input is not correct, then the output is also
Agreed.
not correct. So,
So
I
I
would
want
refrain myself
to
from
agree.
commenting.
So I want to come back to the role of plasma therapy, because now this says that mutations occur specifically if the virus stays in the body of a immunocompromised for 2 months or 3 months. And we have seen in cancer it lasting for more than 120 days. The virus was alive. And in that particular position, they are now talking about the role of plasma in, unnecessary use of plasma late in the illness can help the virus to grow and mutate. Is it correct? Scientifically.
So absolutely correct, because what happens is that virus is known to mutate when you put pressures on it. So if virus undergoes an immune pressure, you are giving plasma to an individual. It has lost lot of host factors as well as some antibodies also there. So whenever virus will face some kind of an immune pressure on it or external pressure, then due to natural selection process, it will mutate. So we are going to see more of these mutations once we start giving the vaccine, because the immune pressure will again increase. So whenever you will increase these kind of natural pressures on the virus, it will definitely mutate.
So I want to now come back to 501 mutation, which is there both in UK and in South Africa. Now 501 mutation is in the RBD, which is a receptor binding domain, which is the main key which is going to put into the lock of ACE2 receptor in my body. And both the England strain and the UK strain has that 501, which is NY, N replaced by Y. I call people remember it like New York. So N is getting replaced by Y. And New Year's, you are getting a shagan of 501 rupees. So this is how you can remember N501 mutation, which is coming. Now, this 501 is in the RBD, but not in the RBM. RBM is from 424 to 494, which is 70 amino acids. This is beyond that, and it is in the RBD. But if you see the clade of the South Africa, which has three major uh, lineage mutations, and that is 417, 484, and 501. All three of them are in the RBD, that is receptor binding domain, and one of them is in the RBM, which is receptor binding moiety. So, do you feel that from that point of view, the South African strain may be a little, but though they are calling them as 501 V2, V1 is being called by the UK, but do you think that's more contagious? That can be more contagious.
So, as I said, sir, whatever we are proposing, the effects of these mutations would be, they are very, very hypothetical and speculative right now. Though what you said is right, since it's there in the moiety, it may have some effects. But the better way to understand the effect of these mutations, and these studies have also already begun in UK as far as my understanding goes, that what the people are doing now is that UK has a population wherein people were infected and have recovered. So people who have undergone natural infection, if you take their serum samples, they are likely to have some neutralizing antibodies. Then there's another subset of individuals who are getting vaccinated and are likely to like elicit an antibody response post vaccination. So in UK, there are attempts wherein both sera from both these populations is being collected, and whenever you have a live virus culture of this mutated virus, if you try to react this virus with the neutralizing antibodies which are present in the serum samples, then you can see whether actually these antibodies which have been raised because of the vaccine or because of natural infection, whether they are able to neutralize the mutated virus. So these are the kind of studies which will actually make one understand that what happens whenever a person is vaccinated. I agree there are speculation regarding the moieties and all, but unless we have this kind of data available with us, it is very difficult to comment on the effectiveness of the vaccines. And these studies have actually started.
So I want to go back to a hypothetical situation that I want to know whether my virus is alive or not after 7 days. I'm talking about a clinical situation, hypothetical, because if I find my virus is still alive after 7 days, I know that it may persist for 20 days, maybe more. It is likely to replicate and mutate. Now, normally we say that this virus will respond and produce a CD4, CD8 response, absolute lymphopenia, with reduction in CD4 and CD8. And we say that the day virus is non-replicative is clinically indicated by rising lymphocytic count clinically. So suppose if I'm following on day 1, day 2, day 3, day 4 lymphocyte count, and on 7th or 8th day, I expect lymphocyte count to start rising. And if they are not rising, I presume the virus is still replicative, which may not be absolute, but it can be a rough indication that the virus is still replicative. So I continue my response at that particular thing. Do you think that some guidelines can come on lymphocytic count and see such cases, immunocompromised, if their lymphocytic count is persistently low, they should not be given plasma therapy or heavy dose of steroid? Or, I don't know. I'm only putting it a hypothetical situation because RT-PCR is not telling me whether the virus is replicative or not. So I have to have a clinical parameter. We can't go and say the literature is not there in the world. It's a time to create literature and not to look for the West to create a literature. So all the time I'm thinking that this can be a parameter, that rising CRP with the following lymphocytes persisting 7th day, 8th day, 10th day, in absence of a secondary bacterial infection, may be a clinical marker of persistent viremia. So can ICMR look into it as a, I mean, I can only give a copyleft. Copyleft means ideas at a private sector we can give and see whether if you think it has a scientific meaning, somebody can look into it.
So I very much agree with what you said, that it is very important to understand whether the what is the kind of viral clearance that an individual is doing at his or her own level. RT-PCR will even detect the dead viral genome. That is true. So you will never know. The other method is to do a virus culture, which is very, very cumbersome. And again, it is not easy to isolate virus in every case. So it is very much desirable to have a surrogate marker, at least a clinical biomarker, to understand whether the virus is replicating or not. So definitely, sir, we do understand the value on having clinical markers for predicting whether virus is replicating or a person is heading for a severe disease or he's recovering. These are very important clinical biomarkers which have to be understood. So definitely we can look into it, and for this purpose, ICMR even commissioned a clinical registry for COVID-19, though because of bringing various hospitals on board, we took some time to execute this exercise. But we have quite a bit of data now within our COVID clinical registry, and wherein we capture all the data on the various investigations conducted and various treatment modalities given, and what how the patient progressed, what were the outcomes. So definitely ICMR can commission some groups of clinicians to look into that data and come out with certain guidelines.
Two more things
Definitely
I
would.
want to say. Two more things I want to say is that the South African people says that this new 501 mutation with 417 and 484 may be more contagious and more transmissible in children. Though they have not proved it, they have written down is yet to prove that this is initial studies says it is more, and if it is true, then definitely we have a lot of naive children population who can get this infection, and maybe may end up into more MIS in the future, multisystem inflammatory syndrome in the children. Any feedback on that?
So far, what we have observed and what we see as per our experience, that the disease severity in children in India, as far as
Very,
COVID-19 is concerned, is definitely very mild, and it just passes on as a mild infection. So any change in the pattern of presentation, clinical presentation of children, is definitely likely to catch the attention of the clinicians because it's extremely mild as of now. So we are definitely keeping a vigil on that. And as and when, if God forbid it happens, then definitely we'll have to tackle it in a very different way.
another copy left, because in the private sector we can only have a copy left. Copy left means we are only anecdotal observations. When I'm reading the literature all over, talking to I'm the president of Confederation of Medical Association of Asia and Oceania. So all these countries we meet every Saturday, and we have been interacting for the last 1 year. All neighboring countries for 1 hour, 9:30 to 10:30, we Singapore, Hong Kong, Japan, we interact with each other. And one of the thing which is coming is loss of smell and loss of taste. So somehow or other, we have an instinct in our mind that this virus in South Africa and UK may be identified by more numbers of loss of smell and loss of taste. It's only instinct. So I'm only giving a clue to watch. Maybe if it is true, I don't know, maybe you may get the answer after 3-4 days that UK comes out with a statement. But from the social media studies, the shift in the social media, talking to my colleagues in all the medical associations, somewhere or the other, one thing which, because today why I'm talking about it, before you came, I was reading a study from Nagpur. A Nagpur person came from England. He was corona negative. A week later, he developed loss of smell and loss of taste. And now they are tracing everybody. It looks like a UK strain. And then suddenly it struck me that why this person has a loss of smell. And then suddenly it struck me that I have been reading about. So I'm just putting a clue, maybe, that this virus may differ in terms of loss of smell and loss of taste. This is not for any comment. This is just an observation which I wanted to put it to ICMR. Through you, maybe we may come back that truly this virus is slightly different into that. Now, another thing which is showing is that this virus, if you see the South African curve, this virus is much faster, much bigger, much faster and much bigger, much earlier. If you, I can show you that slide which I'm trying to mention about. If I can have the slide. This is the slide which shows that you can see here in the first wave, there was no yellow color. And in the second wave, you can see in the last 3 weeks, 90% of them have the 501 plate. That's what which has happened. And this is what I was talking about is the first wave, the difference between the first wave and the second wave. And the second wave is much earlier, much bigger, and much stronger. If that's so, India doesn't have seen till today. We have not seen in India a second wave. It's a single wave, which is now declining from 16th of September. So maybe that we are already towards a herd immunity. The numbers are because the DST study shows in September 1 is to 60. The latest study shows 1 is to 90 for every symptomatic, 90 asymptomatic cases. Maybe that our number may be more than 20% seropositivity rate. And if it is 30, 40, 50 as a guesstimate, and if we give 30 crore people vaccination by 25th of March, then the day we complete 1 year, maybe, this can be an aim that by 25th of March, we want to control before completing 1 year. So all the time I'm thinking about this because in India, we are not, Pakistan, we are getting a second wave. Bangladesh, we are getting a second wave. Then Hong Kong, we have 4 waves. So when we are getting a second wave, not getting a second wave in India may mean that we already are towards a herd immunity. Any speculation on that?
Yes, sir. So what we have been trying to do is definitely to curb the transmission. And though I agree that herd immunity has been achieved in many places due to increased rate of transmission of infection, but the overall aim is to have a mix of herd immunity and vaccine-induced immunity, because we were never aiming for a complete herd immunity in view of the severe disease and losses of lives. And the main aim has been to have a mixed kind of an immunity, and that effort continues.
That's the reason I'm saying if we give 30 crore people the vaccination, in any way 30 crore don't need it because they are children less than 20 and the vaccine is not available for them. So out of 100, if we give 30 crore as vaccination, 30 crore is a natural infection, then you at least end up into a herd immunity by 24th of March, which I am aiming at, which means what I am basically working on creating awareness that I'm basically talking about vaccine hesitancy. So I am speaking all on my shows that kindly take the vaccine, because if everybody takes the vaccine, maybe by 24th of March, we may be able to control the disease. Whether we control it or not is a separate issue, but at least with this, vaccine hesitancy can go away, which is now becoming a source of concern to all the world, all the countries in the world. So I'm very grateful to you, Nivedita ji, for having come here. It was a wonderful interaction. We will be sending this link to all the doctors in the country. And I think every doctor in the country must watch this video, because this virus has taught us, go back to the basics, relearn your anatomy, physiology, biochemistry, virology. There was a time we always used to say, virus, give this drug. Now it is telling us structure of a virus, what are enveloped virus, what are non-enveloped virus, the genes, the genomics, the subjects which was very, 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 very ill understood in medical college, that is immunology and virology. This is now telling us that we need to do it. I'm going to end by saying that US has shown us that I am not the best as far as corona management is concerned. If that's so, Mera Bharat Mahan, all of you work hard, learn virology, learn genomics, work hard, work with ICMR, and make our country the best in the world. That's all for today. We'll be back tomorrow 7 p.m. with another show. Keep watching Med Talks with Dr. K.K. Agarwal. Thank you. Namaskar. Namaskar, Nivedita ji.